Welcome to Web Handling. My name is Dave Roysum. I am super excited to continue Dave's Defects with a brief introduction to web breaks and other runnability troubles. Much like the last clip on vibration, we could talk for hours on the subject, but that would take me many days to write and video render. Much like the last clip, we can only give an overview of the issue in this short course. Much like the last clip, I will give you many resources for learning more at the end of this post. We will begin our careful definition of runnability here as the mean or average distance between troubles, such as web breaks, jams, defects, and so on. The average distance can be quantified in any suitable length units, such as million feet, 100 rows, and so on. In the paper industry, where much of the study of runnability had begun, the common units are breaks per 100 shipping rolls. However, we must tighten the definition because obviously some materials run better than others. Newspaper and tissue, for example, break more often than steel, even though steel also breaks. Even with nominally identical materials such as newspaper, the runnability can vary by an order of magnitude or more between two rolls from different suppliers. We must further tighten the definition because some sections of a machine run worse than others. We now have the elements of a material machine system rather than a black and white, is it the material or is it our customer's machine, silly question. Finally, we must tighten the definition yet again to include important operating conditions such as tension and speed. Thus, we now have the elements of the full man-machine material system as described in my 2-day problem-solving course. Some materials run better than others. However, because defects are usually statistically rare, it may take thousands of rolls to tell whether one material or one machine condition is actually better than another. Further complications include environmental or seasonal effects at both the producing location and at the customer. For example, newsprint printing presses have twice as many web breaks in the dry winter months as in the summer months. When we troubleshoot runnability, we must look at the roller level rather than the machine level. For example, we might find many web breaks occurring near a process, perhaps leading us to suspect that the process is rough on the web, perhaps avoidably so. On the other hand, we might find that many web breaks occur just after the unwind, indicating that maybe the unwind is troubled, or maybe the web is so troubled that it gives up on the very first opportunity. Once we know where we're having the most trouble, we can then focus a camera or other instruments. In web breaks, we can use either high shutter speeds or high frame rate cameras. Both require extremely good lighting. Even more information might be more simply found at the break initiation point, which occurred somewhere along the crack. Make every effort to find both ends of the tail. Make every effort to document the material and process details while they are still fresh. In newsprint, for example, most breaks start at a shive. However, almost all would begin at some point of contamination. The contamination can be water, oil, or something else, or even the material itself, such as the case of paper shives and film gels. I teach how to read a web break in one of the optional modules of my award-winning and trademark Web 101 class that has been taken by 5,000 people. Have you ever thought about the when and where and why of your breaks and other runnability issues? Web breaks are almost always complex system issues. They include applied tension and web strength. However, the local load can vary enormously due to both mechanical and control design or maintenance shortcomings. That is why we did the web break histogram in an earlier slide. For example, an invisibly small roller misalignment can increase web breaks by a factor of 10. Just as with load, local web strength can vary by an order of magnitude between one location and a nearby location. So, web breaks, as well as other runnability issues, are more defined by variation than they are by averages. The average web simply does not break. Average web strengths, such as reported by a test lab, may be worse than worthless. They may be misleading. Here is an example of a very strong material that runs quite poorly because it is also variable. I worked on just such a system on a brand new winder in Canada where the mill manager had difficulty believing that variability could wash out all of the benefits of an otherwise strong web. I, as well as many people before and some after, have studied runnability as a property of a material that can be measured using specially configured lab machines. What we found is that web breaks increase with the second or third power of tension. Not only average tension, but local tension caused by poor web machine mechanicals and poor web machine controls. For example, the web break rate may be 1,000 times greater during a speed ramp than during steady state. Also important in web breaks are stress concentrations and fracture mechanics in the case of brittle materials. Flaws that are big are worse than when they are small. That is obvious. Flaws that are near an edge are twice as serious as those that are in the middle. Finally, flaws that have a sharp radius, such as a crack, are 1,000 times worse than a smooth hole everything else being equal. These principles are not just true of paper. In the metals industry, they mark splices with 3 holes. The combination of the holes, the stress concentrations of the holes, and the proximity to the splice increase the web break rates at a splice 1,000,000-fold. This shows a lack of awareness in the metals industry and a total lack of common sense, and finally a paralyzing slavery to status quo in machine design. I promised you a list of references for further study of the subject of runnability. You could do no better than to start with the optional and advanced Module 36 of my award-winning and trademarked Web 101 course. Then you could search the free and easy Roysum library by Abbott App, and you will find more than 100 articles on runnability, mostly from the paper industry. If you want a good overview with a great selected bibliography, you could do no better than my classic 1990 article in the Tappy Journal. Thank you so very much for joining me in this defect solving and defect preventing series. Stay tuned for the next clip where we talk about a very popular topic, wrinkles. If you have a defect you would like to hear about, let me know in the comment section below. If you found anything interesting or useful here, please like and share and subscribe. Also, please consider supporting the work of this channel using the Patreon link below. See you next time.